Hey, good morning. We are doing 11.9. This is linear, quadratic, and exponential models. So in our call last week, I told you that there was one that I thought was a really funny joke. I know they're really all stupid, but this one, because it's linear, quadratic, exponential models, the teacher asked the student, "Why are you so dressed up?" And the student said, "Because you said we'd be modeling today." You're welcome. Okay, so we are going to be talking about these. In a previous video, I talked about linear. I know you should remember this. Linear means line. Quadratic is where you have the U or the parabola, and the exponential is the one where it'll look like it gets really, really close to the axis, and that's about as far as it will go. So you're going to be given some information. You'll be given like 4 or 5 points that it'll ask you to plot on a graph. If you plot points and they tend to go like this, if you were to connect them, they would create what looks like a line. So you can guess that it would be linear. If you get points that tend to go like this, like they could create a parabola, then you would say that they are quadratic. If you get points that go like this, and they start getting really close to each other, and they go like that, then you would work with exponential, okay? So your first step is you're gonna be given just some points that you wanna graph, plot them on an X and Y axis, put it on a coordinate plane, and you'll be able to tell by the way that it looks what it is. If it creates a line, it's linear, creates a parabola, whether it faces up or down, it is a quadratic, and then exponential is the one that just gets really close to each other and closer to a line, okay? Let's go ahead and look at this. So we have seen each of these in action, but I want to show you the relationship that they have to each other. So this is, we know according to the function rule or this equation that it is a linear equation. Your x side, you're always going to add a constant just to be able to see, because the x is what you plug in. That's the independent variable. So once you get the results here, look, it looks like in this one, I subtract 3, I subtract 3, I subtract 3, and I subtract 3 again. So with your linear, you have a constant and you're going to have differences or the total sum. I couldn't think of the word. You'll either have sum or differences when you're going through the dependent variables. Well, the quadratic, it should wrap back around. So here, I'm going to subtract 6, I subtract 2, and then it wraps back around, so then I'm adding 2, and I'm adding 6. So that's what a quadratic goes down and then up, or it goes up and then down, okay? You're gonna have constant differences and then constant sums. So there's the difference there. I'm gonna use a different color just because it's the same here. So this is with exponential. Again, I add down the x side just because those are my independent variables. That's what I'm plugging in order to get a result. And here it looks like I could add 2, but I also multiply by 2, and there's my rule. I multiply by the same thing each time. That looks like a plus sign, but it's not. I multiply by 2 each time, okay? So here I'm adding or I'm subtracting by a constant. It's not a constant, but I go down and then up, or I go up and then down, depending on whether it's a positive or negative quadratic. And then here I have a common constant that I multiply by. And it can be a fraction. If it looks like I'm dividing, if it's getting smaller, then I'm actually multiplying by a fraction. Okay, here are examples of our equations. Y equals mx plus b is linear. Okay, anytime you have ax squared or x squared, this is the formula though, ax squared plus bx plus c. Remember when we use the quadratic rule, the quadratic function, this is, if you remember it, negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, that's our quadratic formula. And then this is exponential. So these are the ways that they look. Now what you're doing today is you're actually going to be working with all 3 of them. You will have points that you'll need to plot, you'll have graphs that you'll need to graph, and then you'll have a chart or a table or a list of points. And they want you to look at it and find that rule. Am I adding or subtracting by a common difference, a common constant? Is it going up and then down or down and then up so that it creates a parabola? Or am I multiplying by a constant each time as I go through that result, okay? Good luck, ask questions if you have it. I'm here for you, and I will talk to you soon. Bye.